Welcome to the Glad Labs podcast. Today's episode, why your Postgres app will crumble before your first user, and how to stop it. You built the perfect app. The user interface shines, the logic flows smoothly, and your Postgres schema looks elegant. Then, during a live demo, the database suddenly grinds to a halt. Users see errors. Your dashboard flashes red. You realize too late. Your app wasn't built for production. It was built for a demo. This isn't a rare failure. It's the silent killer of countless applications. The good news? Fixing it isn't about magic. It's about knowing what to build before you build it. Let's cut through the noise and build something that lasts. Most developers treat their database schema like a first draft, functional but fragile. They add columns, tweak relationships, and assume it will work until traffic surges. This is where 70% of production database failures begin. The Postgres documentation clearly states, a well-designed schema is the foundation of performance and maintainability. But what does well-designed actually mean? Start with intent. Ask yourself, what data will I need in 18 months? Not just what my current feature requires. Then, enforce that design. Use check constraints for business rules. For example, adding a constraint to ensure order status can only be pending, shipped, or canceled. This isn't just about data validity. It's about preventing bad data from ever entering your system. Many teams skip this step, only to spend weeks later debugging corrupted records. Next, normalize just enough. Don't over-normalize into a maze of 10 tables for a simple user profile. But don't denormalize prematurely either. A common mistake is storing aggregated data, like total sales in a user's table, which becomes hard to keep accurate. Instead, use materialized views for expensive aggregates. Postgres' materialized view syntax is straightforward. You can refresh it during off-peak hours using the command refresh materialized view concurrently user summary. This avoids bloating your main tables while keeping analytics fast. Teams that adopt this avoid the panic of a slow database during reporting. Finally, document your schema evolution. Every change to your database should include a comment explaining why it was needed. When a new engineer inherits the database, they'll understand the trade-offs, not just the code. This aligns perfectly with the principles of building production-ready systems where infrastructure decisions are as critical as the code itself. You've got a query that runs in 20 milliseconds of development but takes 2 seconds under load. You blame the server. You don't. You blame missing indexes. But adding an index blindly can cripple write performance and cause lock contention. The real mistake isn't adding indexes. It's adding them without understanding your data access patterns.